printing news Unpeeled. And today we have some news from Boston Micro Fabrication. Now, the Micro Fabrication company already made some big news last week when they raised 24 million Series D round. Smaller than the Series C, but nonetheless a significant achievement in today's fundraising climate, which is, well, I was about to say far from ideal, but I think we can all agree that it's horrible at the moment. So that was already really good news. And now they're doing something, well, I think even more interesting. So what they're doing is they've just come up with something called UltraThineer. This is something they've collaborated with some university researchers and stuff to come up with a cosmetic dental veneer made in zirconia using 3D printing. Now, as we know, 3D printing for ceramics is already a really, really burgeoning market. A lot of people want to expand into it, and 3D printing for dental is already huge and growing very quickly. So in this case, what they're doing is they're using their projection micro stereolithography machines to make a veneer that's 3 times thinner than other veneers. The idea behind that is that they have to do less tooth preparation, essentially, to put the veneer on. So that means you retain more of your tooth, which is always good, and may even be less painful, quicker, all that kind of thing. The company hopes to get FDA kind of approval for this stuff in 2024. And this is very interesting because, okay, so first off, Boston Micro Fabrication makes machines. And of course, every once in a while, you run into all these applications. Usually it's the client that comes to you. So first off, how do you engender this? How do you stimulate people to make applications on your platform? Work with researchers is good. Reach out to researchers, help them with like things like design for additive manufacturing, stuff like this. Give them free stuff often helps as well. Give them free materials and stuff like that. Also inspire them with models and parts and cases that really tell them what the costings are and what the limitations, what the advantages are of your technology, that kind of stuff. So it's not, and you have to do a lot of outreach. You have to talk to a lot of people. And then every once in a while, you end up with something like this. Now, the interesting question I want to pose to you is, what would you have done? Boston Micro Fabrication is an OEM. They make machines. And the logical thing is to say, look, guys, we're a machine manufacturer. We just continue making machines. But every once in a while, you'll come up with these applications, right? And these applications could be much, much bigger than your whole the market that you're targeting or the cash that you're going to generate from that market in the near term. Or there can be unique opportunities. So you need to actually, as an OEM, grapple with this. Like, first, how are we going to ensure these capabilities or these applications? How are we going to help bring them to market? And are we going to play a role? Maybe as a kind of an incubator or an investor, maybe just as a kind of more of a cheerleader, not putting your money at stake, but helping these people develop stuff in your technology. Or maybe doing spin out companies or kind of like your own brands and these things. Now, all of a sudden you're getting different risks. You need different types of people for these type of businesses, different types of a way of doing business. So it's risky to do this, but I think, think about Invisalign, right? Invisalign itself, it's an absolutely huge application for 3D printing, right? It's the 3D printing market, maybe like, let's say revenue 15 billion or something like that. Invisalign itself is 3.2 billion, right? Market cap of Invisalign is 26 billion. And these are the guys printing like a million or more of these dental aligner molds using 3D printing. And that is hugely valuable. So imagine that they could have a similar, or even like a tenth of that impact just with this one application. It'd be huge for Boston Micro Fabrication. But again, do you do it? Do you go for it? So I think this is a really interesting discussion. I think that the company should have is either you encourage it, you spend a lot of time encouraging it, or you actually actively take a stake. There's other ways of doing this. Like Victrex is a company that makes a material. They make PEEK, not all of it, but a lot of it, or PAEK materials as well, the whole family. And what they do is they'll sell you PEEK pellets or filament or powder, right? But for the medical stuff, they'd like to keep it themselves. So they want to keep that under control. It's safer for them. And of course, they capture the value of making these really high-end PEEK medical devices. So that's a way you could do it. You could segment a market and say, hey, whatever you want to do is fine. Medical's mine. And that, I think this is a really interesting thought experiment for strategy people, but it's also something you need to look at now as an OEM, because selling boxes is slow, and selling boxes is not necessarily the best business to be in. But doing, a bunch of things at the same time could actually be a very, very bad business, because you could just end up not making good machines, which won't help your applications one bit either. But anyway, I thought this was really something to think about. This UltraThineer by BMF. The other thing to think about today is the National Institutes of Health. This is an unrelated image. This is a related image from some other research on 3D printed pills. I couldn't find something on this, or couldn't really find a relevant image of this thing, so it's a different, but around the same subject matter. Today, we learned that the National Institutes of Health has awarded $3 million, a princely sum, to pediatric oncology tailor-made doses. Now, tailor-made 3D printing doses is another thing that I think could really be a huge part of business for us, much bigger than our existing business, and much bigger than many other businesses that we are active in. A lot of people are focusing on aerospace and cars. That's wonderful. But this could pay a lot more and could also be a lot more relevant. Think about something like pediatric oncology, where the mortality rates are very, very high. The impact is very, very high on people's lives and on the amount of years lived and things like this. And think about the research being done, and think about the difference of kid size. Like adults, some adults are much bigger or whatever than other adults, but kids, they vary enormously in size. And they vary enormously in size, maybe even throughout the treatment. Maybe your 11-year-old becoming a 12-year-old, becoming a 13-year-old, become a much bigger person, for example, much heavier person. So these kind of things really could have significant impact, let's say. So what they've done is they've given that money to Texas A&M University. What's nice to see here is that this College of Engineering, the College of Pharmacy, and the Biomedical Science faculty will all be working together on this. Love this. And that'll be coordinated by Mathew A. Kuttolamadom, which I hope I'm pronouncing his name correctly. And they're going to look at the size and the dosage, right? And looking at these variations in doses and how they can optimize this, and also multiple medicine. This is one of the things that I'm the most excited about, this polypill or multi-pill kind of delivery mechanisms where, imagine you're a kid, you have to take lots and lots of different pills at lots of different times. Imagine we can make them much simpler. For Tim, we print this pill, and this is one pill you take that day. And then we make sure that the release kinetics on the pill mean that we have a fast releasing drug that is printed with lots of holes in it, for example, on the surface, and then inside there's a drug that's encapsulated by material, and that takes a lot longer to release, for example. And that, imagine how much simpler that makes your life, and imagine also we can make some treatments more effective as well. Like the application area of pediatric oncology, like this, and I think this is an area that's overlooked. There's only like a couple of startups in this area, maybe a handful. And I think given the potential here, and given the potential to make healthcare better by personalizing it, this is huge and completely overlooked business opportunity. Now, okay, there's one thing I do want to tell you before I send you all off into happily exploring this. Just because personalized medicine looks good and feels like it's a logical thing, doesn't mean the efficacy of this will be worth it or bring about other kind of risk or other kind of problems. We must realize that, it seems really logical, right? We have a certain medicine. We all have different weights. If we adjust the weight to the medicine, then oh my God, everybody gets the right dose. But it could be much more complicated than this. There could be many, many different factors from many different medications. It could be have to do with my biome or levels of acid in my stomach or whatever. There's tons of different personalization factors. And we must not forget that just because the idea of personalized medicine sounds good, that does not mean it's going to be more effective. And even it may even be less effective or even more confusing or not lead to any benefit whatsoever, because we're just not encapsulating all these personalized differences that may have more impact or different types of impact. So, but having said this, super excited about release kinetics, better release kinetics, polypills, combinatory medicine kind of stuff. I love it, love it, love it. So the next thing is news from the new space race. So this is BLT, otherwise known as Bright Laser Technologies, which is essentially telling us all about its role in the Landspace Zhuque-2 Y2 rocket. This was there was previously an unsuccessful launch. This is a successful in the Zirconia satellite launch center in China, and some components on this, they're being a bit vague, were made on the BLT S310 and the BLT S400 machines. Not the giant ones they have, but kind of their medium formatish kind of laser powder bed fusion machines. This is notable, I think, because we're seeing a new space race. Now, a lot of the money has been going to the United States of America, and the United States of America has used mainly US machines or also European machines. Now, Chinese vendors are trying to sell really large machines. Now, there's really large machines. Why do you want a really large machine? Yield? You want to make lots of parts? No. You want to make a really big propulsion chamber in one piece. That's the really thing driving, or a part for hypersonic, or a warhead for a missile, something like that. So if you see these really big machines, That's what's driving growth of this. It's the Air Force Research Lab. It's new space companies buying a whole lot of these because they want to make their propulsion units in an optimized way with fewer parts, with less weight, and be able to redesign them quicker as well. Now, in that case, we're seeing this being thrust forward. And imagine how important this is. Imagine you can just make a little bit better thruster engine, or a little bit more efficient. Imagine what the economic impact is. Or imagine just you have an order for 100 of these things, and it will take you normally a year to fulfill them, and now you can bring that back to a month. Yeah, that impact is just really significant. Many billions of dollars impact across the line here. But what we're seeing is we're seeing a divorce, and it's happening in the rest of the additive market as well, where Western companies, if you will, if we use the term still, are not buying Chinese machines, and Chinese companies are not buying Western machines. And there's like kind of a divorce. And what some Chinese vendors are trying to do is, but we'll try to penetrate certain markets, like, for example, countries around Europe, for example, or other markets, or more lower value markets, in order to say, hey, if we sell to China and a part of the world as well, then of course they're going to have an advantage, right? Or if they sell to a market segment like tier 3 suppliers to automotive or something, then they'll be able to sell more machines, and that will make their space race faster, of course. So we're seeing this really interesting thing. It's about ITAR and all these other regulations divorcing these markets essentially from each other. And we're seeing a Chinese technology stack being developed, and a kind of like non-Chinese one. And that's something we should all notice. We should be cognizant of this. I don't know what the implications of this are going to be, and it's very early days, but it is going to happen, and it is happening. We see evidence for this every day. So that's something to take into account. My name is Joris Peels, and this is 3D Printing News Unpeeled. Thanks to 3dprint.com. I hope you found this valuable, and you have